Oi lads, Dan here today bringing you lot a lovely video. In today's video we're going to take a look at how to solve the integral of ln x dx. Before we jump into it, I want you lot to leave a like and subscribe and let's get right into it then. So the way we solve this is we use a special technique from integral calculus known as integration by poles. And the formula that represents integration by poles is this formula on your screen before you. Right, so we have the integral in this format, u dv, right? In this case, we have a u and we have a dv term. Right, so the way we do this is we need to select a u variable and a dv variable from the integral of ln of x dx. And the way I like to do these types of integration by poles is I like to imagine there is another variable multiplied with the ln of x. And the variable I see multiplied with ln of x is basically 1. In this case, we have 1 times ln of x, which is equal to ln of x, but picture there's a 1 multiplied with ln of x. Therefore, we got a u and we got a dv variable that we must choose. And the way we do this is we use a special chart to basically help us determine which one is our u variable and which is our dv variable. So in this case, we have a ln of x, which is going to be denoted as a logarithmic function, right? So it's going to belong right over here. And I told you to imagine there's a 1 being multiplied to this ln of x. Therefore, that's a polynomial. So it's saying that the polynomial is going to tend to dv and the log is going to tend to u. So therefore, it's telling you to take ln as a u variable and dv as your polynomial. In this case, is equal to 1. So once we have established this, we are from the left hand side, the two boxes, we are going to take the derivative on both sides of this equation. So when you take the derivative of u, you're going to have du, and the derivative of ln of x is 1 divided by x dx. On the right hand side, these two boxes, we are going to do the opposite. We're going to take an integral. So the way we go from dv to v is by taking an integral, and therefore if you take the integral of 1 dx, you are going to have just x basically. So according to the formula, we are going to replace these variables inside this formula right here. So let's do that right away. So our u variable is going to be ln of x times x, which is our v variable, subtracted by the integral of x times 1 divided by x dx. Notice straight away the x's would cancel out basically, and what you are going to be left with is ln of x multiplied by x subtracted by the integral of 1 dx. This integral is very straightforward to solve. That's just going to be equal to x, and what you are going to be left with is x ln of x minus x plus c, and that's how you solve the integral of ln of x dx. So if you lot enjoyed this video, please drop a like and subscribe, and I'll see you lot later.